Hello everybody, welcome back. Today we're looking at 4.3, the ambiguous case of the sine law. So the ambiguous case of the sine law is a situation where two triangles can be drawn given the available information. So if you don't have a diagram, we could have two people draw two different triangles that have the exact same information that are correct. Yes, that you're hearing that correctly. And that situation is when we have SSA. Two sides and an opposite angle. Okay, so let's take a look. We're going to explore this. I think this is the best way to take a look at this. And I've provided you with all these in notes in your handout already, so you don't have to copy this. You can just watch and look at the scenario. So the first thing we're going to do is we're connecting the SSA situation to a number of possible triangles. So that's side-side angle, right? Side, side, and obviously one of those angles correspond to one of the known sides. So let's look at a right angle triangle for the height, for example. So let's say we had a scenario. And look at all these scenarios. All of these scenarios have an angle of 30 degrees for A, and they have a B of 12. The only thing that's changing is the opposite side length. And the book uses 4 different measures here for the opposite side of angle A. Okay? And obviously that would be the height here. This would be considered A. Opposite of 30 degrees. So on a right angle triangle we saw for height, we get a height of 6. Okay? So that's scenario B. Okay? What if we make the height smaller? So if we have this triangle 30 degrees, we have side B is equal to 12, and if our A value is 4, it's not long enough to create a triangle, so there's no possible triangles here. Alright, so that's the scenario when side A is less than side B and side A is less than the height. Okay? Remember that we calculate the height to be 6. Alright, that's side A. Okay? But if we're given side, for the initial diagram, but if we're given the side A at 4, it's not long enough. Look at scenario B, or situation B, where if side A is still less than side B, but side A is equal to the height this time. That was what we have up here in the example of the right angle triangle. So let's create one right angle triangle. Okay? Let's look at another scenario. Situation C. In situation C, we have the A value still less than the B value, but the A value is greater than that height of 6. This is the ambiguous case. You could actually create two different triangles. The first one here being the obtuse triangle, and the second, the larger triangle, being the acute triangle. Very interesting scenario. Okay? And then we have situation D, where side A is greater than side B. Alright? And if this side 15 were to swing here, it would never come back to create a triangle. It's too long, essentially. So this is just the one acute triangle. So this is the situation C is what we're interested in. Okay? This goes back to an example that we had, and I talked briefly about it the other day, is remember when we had the sine of 30 degrees, and then we had the sine of 150 degrees, and they equaled the same thing? This is why. This is one of the reasons this is occurring. So situation C shows how two triangles can be drawn given the available information, hence showing the ambiguous case that occurs during SSA, side-side angle. Let's look at the second example, folks. Solve a problem using the sine law. Martina and Carl are part of a team that is studying weather patterns. The team is about to launch a weather balloon to collect data. Martina's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. Carl's rope is 5.9 meters long. Assuming that Martina and Carl form a triangle in a vertical plane with the weather balloon, what is the distance between Martina and Carl to the nearest tenth of a meter. So there's a couple situations you could draw here. You could have Carl on the west side of the balloon, and you could have Martina on the east side of the balloon. Or you could have Carl and Martina both on the east side of the balloon with all the same data. Both strings are, like both ropes, I should say, sorry, not strings, ropes, are the same length. There's still a 36-degree angle between Martina and the ground of the balloon, the angle of elevation, which is very interesting. So what we do is we calculated the height here. Okay? So if we had a right angle triangle, right? So I calculated the height using Martina's information. And I got a height of approximately 4.6 meters. So I'm going to calculate this using both the acute triangle and the obtuse triangle. And when you calculate this, you'll see the information. They both give us 50.99. But obviously this at theta can't be 50.99. Doesn't make sense, right? So what we look at is we're going to subtract the 36, right? Oh, sorry, we subtract the given angle from 180 and we get 129, right? Which would make this angle B up here a little smaller. See, the B angles are different. And obviously the C angles are different because it's still, you have to have three angles adding up to 180. So there's two different scenarios here. There's a scenario where we have the distances are going to be, so we found x using the law of cosine, and we got 10.0 meters. So that makes Carl and Martina 10.0 meters apart. But in the second situation, they're only 2.6 meters apart, using the same data. This is the ambiguous case. Super interesting. And again, it goes back to, if you take the sine of 50.9223 and you take the sine of 129.0067, both of these will give you back the same number, 0.7770. And I'm going to show you that on the calculator. So what I've done is I've made sure my calculator is in degrees, and I'm going to take the sine of 50.9932. Again, this is rounded, a rounded angle, so it's not going to be exact, but you're going to see that it's very, very close. Then I'm going to take the sine of the 129.0068. And you'll notice that the number is indeed the exact same initial, right? So interesting. And that's because the other day we learned that it's the sine of 180 minus theta. Theta was 50.9932. We get the same thing. And that's that 0 to 180. The sine is always positive, which gives us a positive value back. Now, some of you are still, so why is this happening? Well, we will learn about this in greater detail when we take Pre-Cal 11 and Pre-Cal 12, when we do the trigonometry unit in those courses. But for now, we just need to know that there's two possible triangles. An acute, like we learned in Chapter 3, an obtuse, that we're doing now in Chapter 4, that will give you the same information. Your calculator, when you do this, will only give you back the 50.9223. You have to take the 180 minus that to get the 129.0068. Super neat. Okay? Again, that's why there's two scenarios and two possible distances between Martina and Carl. Nowhere in the question did it say that Martina was on the east side of the balloon and Carl on the west. Okay? Basically from the diagram. Left or right, I guess you could say. Next, we have example 3. It says Leanne and Carrie are hiking in the mountains. They left Leanne's car in the parking lot and walked northwest. So there's the parking lot. they were northwest for 12.4 kilometers. Then they turned due south and walked another. So due south means directly go vertically down here, right? Okay, 7 kilometers. The weather was taking a turn for the worse, so they decided to plot a course directly back to the parking lot. So their current position directly back to the parking lot. Carrie, remember from the map in the parking lot that the angle between the path and the campsite and the path to the Glacier Lake measures about 30 degrees. What compass direction should they follow to return directly to the parking lot from here to here? So we're looking for basically this angle. If you would continue this down, this angle right here is what we're looking for. So we do the law of sines. We know an angle the opposite side. We're looking for an angle with the given opposite side. So we use the law of sines. We figure out that theta is equal to 62.3395, which we obviously know this is not correct, right? So it's bigger than that. So that's because, again, the ambiguous case. This will only give us an answer between 0 and 90. Okay, this will only give us an answer between 0 and 90. So we got to take 180, subtract that value. So this is the actual angle of 117.7 or 117.6604 to be exact. So we say that's approximately 118 degrees. So that's from this here. We're plotting this as our origin. So that would give us 118. So to get 62 degrees, it's this angle right here. From the vertical to there, like we learned the other day. So 62 degrees east of south. 62 degrees east of south. So that was just 180 minus 118. And there you are. So Leanne and Carrie would need to travel in the direction of 62 degrees east of south to reach the parking lot. And that's it for section 4.3. There's some homework questions there, page 183, number 4, and 7 through 11. Thanks everybody for watching, and I hope you're enjoying the videos, and we'll talk again soon.